Hello everyone, welcome to Code Grads. And today in this session, we'll see the implementation part of the chains that is used in the LangChain. So first of all, let's start with the definition. What are chains? What are chains in LangChain? Now we can define chains. Chains are sequences that link multiple components. Multiple components like the LLM from template, then the retriever or tool. Now LangChain provide building building chain types to help orchestrate the workload. So this is the definition of the LangChain. That is the chains which are used in the LangChain. It is basically used to link multiple components as we have discussed, like the LLMs from template, retrievers or tools. Now we'll see the main types of chains in LangChain. Main type of chains in LangChain. Now first is the LLM chain. And second we have the simple. First one is the LLM chain. Second one is the simple sequential chain. Third one is the sequential chain. Fourth one is the retrieval QA chain. And fifth one is the conversational retrieval chain. Conversational retrieval chain. Okay. These are the main 5 types of the chains using LangChain. Now we'll start. First of all, we'll install the required libraries. We'll install the required libraries. First of all, we'll get the Google OpenAI key. So from google.colab import user data. And we'll mention OpenAI key equal to user data dot get OpenAI, and we'll bring the key in our environment. So import OS and OS dot environment OpenAI API key equal to OpenAI key. Okay. Now this is regarding the OpenAI key. Now we'll install the library. So keep install OpenAI, then LangChain and ChromaDB. Now we'll see the next one. That is the first chain we'll see, the LLM chain. LLM chain. That is the basic prompt chain. Basic prompt chain. For that we'll from LangChain dot LLM import OpenAI, and for prompt LangChain dot prompt import prompt template and from LangChain dot chain import LLM chain. Okay, we'll set the LLM as OpenAI and temperature will set as 0. Now we'll build a prompt. So prompt equal to prompt template from template, from template, from template, and I'll mention the prompt. So suppose what is a good name for a company that may product. Okay, this is my prompt. I'll mention the chain. Chain is equal to LLM chain. LLM chain. I'll mention the LLM. LLM equal to LLM and prompt equal to prompt. Prompt equal to prompt. Okay. I'll build the chain. Now we'll see response. Response is equal to chain dot run. And suppose I ask solar panel. Okay. And I will say print, that is the LLM name response. I'll mention the how it works. So we need to install the LangChain community too. Now after installing the LangChain community, we run the cell. And our question was solar panel. That what is a good name for a company that makes product? And we mentioned solar panel, and we got the answer as Solar Tech Solution. So this is the working of the LLM chain, which is the basic one, and we have built the basic prompt chain using the LLM chain. Now in the next step, we will build the simple sequential chain. Next is simple sequential sequential chain, that is the one input and multiple steps. Now we'll import the simple sequential chain first. So from LangChain dot chain import simple sequential chain. Okay. First of all, we'll mention the chain one, and suppose that is the company name. Okay. So prompt one will be from template, prompt template, and from template, I'll say suggest a name for the for for a company that makes product. Okay. So my first prompt is that it should suggest a name. Whatever the product I will mention, it will suggest a name for a company that makes that product. And I will mention the chain here. So chain one would be LLM chain, and I'll mention the LLM equal to LLM and prompt equal to prompt one. Prompt one. Okay. Now my second chain is the tagline from the company. Okay. So prompt 2 equal to from template, and I will mention write a tagline for a company. Write a tagline for a company name, and that will be company. Okay. So whatever the company I'll mention here, it will give the tagline. I'll mention the chain two, LLM chain, and I will mention the LLM equal to LLM and prompt equal to prompt 2. Okay. Now these are the two different prompts and two different chains I have built. I want to combine these two different chains. So next step is combine them. So what I'll say, simple chain, suppose simple chain equal to simple sequential chain. Okay. And I will mention the chains now, different chains. We have two chains here. So chains equal to chain 1 and chain 2. Now these are the two different chains. I will mention the verbose equal to true. So it can show how the inner operation is there performing. And then I will say output equal to simple chain dot run. I will mention suppose eco-friendly clothing. Eco-friendly clothing. And I will say print simple sequential chain output. I will mention output variable. When we say verbose is equal to true, it will show the inner operation. Now, for first, what we have mentioned, eco-friendly clothing. Now, for eco-friendly clothing, we have mentioned to suggest a name for a company that makes a product. So, it has suggested the company that makes the eco-friendly clothing product, that is a green thread operation. And in the second chain, we are that the prompt was write a tagline for a company name, company. After getting the output from the first chain, that is the company name, we pass that to the second chain for creating the tagline or getting the tagline for the company name. So we got the tagline that is the stitching sustainability into every red. So in this way, we have in the first step we have created a simple chain where we had only one chain, and we told the basic working of the prompt was to get the good name for the company that makes the product. And in chain we have combined the LLM here first of all with the prompt, and then we ran the chain and we got the answer for the question solar panels. We got answer as solar tech solution. So we know the basic working of chain. Basically, it is to create combine the multiple components. Now in this chain we have combined LLM as well as prompt. Now how we could combine multiple chains here? So in this simple sequential chain, we in this chain we have included multiple components like LLM and prompt. This is the chain one. This is another chain two, which has the components like LLM and prompt. And then we have combined these two chains. We have mentioned the simple sequential chain, and we have the chain 1 and chain 2. In chain 1, we needed to get the company name that will make a particular product, and in second chain, we ask for the tagline for the company which was provided by the first chain. That is a simple sequential chain, one input and multiple chain. Now we'll move on toward the next. We'll see the sequential chain, that is the multiple input and named output. Next one is sequential chain. Okay, and here we'll give multiple input and named output. Okay. First of all, we'll import the sequential chain. So from LangChain dot chain import sequential. Okay. Okay. Now first step. Step one. Step one. Generate. Suppose company name. So we'll build the prompt one for the first chain. Prompt one equal to prompt template, and from template I will mention that name of startup. Name of startup for a for the product. I will mention product. Name of startup for product. Okay. And chain one would be LLM chain. LLM chain. I will mention LLM equal to LLM prompt equal to prompt one. And here one more additional would be output key. Output key. That is the company. Okay. Now this is the step one. We have built the chain where the components are the LLM and the prompt and the output key, and we have combined them into chain one, and that will generate a company name. Whatever the product we will mention, it will name a startup, and their output key would be company. Now in second step, we would generate a mission using the company name. Generate a mission using the company name. Okay. So prompt two would be from templates, and from template we'll say what is the mission of this company. Company. Okay, what is the mission of company? Now, what is the company? Yeah, what would be the output of the first chain? So that is the mission of the company. And then we mention the chain 2 equal to LLM chain. I will mention the LLM equal to LLM, and I will mention prompt equal to prompt 2, and I will mention the output key. Output key equal to mission. That will be the answer of the second chain. Now we'll name the input and output with sequential chain. So next would be sequential chain with its name, input, and or output. So sequential chain equal to sequential sequential chain sequential chain. And here I'll mention the chains. What are the different chains we have used? The first would be chain 1, and second would be chain 2. Okay. Now here input variables would be the product. We'll mention input variables product, and output variables will be company and mission. Output variable is company, and first output will be the company and second output will be the mission. So company and mission. And last coordination, the verbose equal to true. Then I will mention the in result variable. I will mention sequential chain dot run. First of all, I will mention the product. So my product will be biodegradable biodegradable plastic is my product. So first of all, we mention it will get the startup for the biodegradable plastic, and then this output would be passed. Now, what would be the output? The company name, that is startup, and it would be passed toward the second chain. So in this, we will pass the company name, and we'll see what would be the mission, and we will get. We will get the company as well as the mission as the output variable. Input variable will be only one, that is the product. Okay, I will print sequential chain output. I will mention the result. So for this sequential chain dot run was not working. We used dot remove. After that, we got the output, sequential chain output, product biodegradable plastic, and we got the company as Ecoplastic. And mission is the mission of Ecoplastic is to provide sustainable and environmentally friendly solutions for plastic waste management through innovative recycling process and the production of high quality recycled plastic products. We aim to reduce the negative impact of plastic on the environment and promote a circular economy by creating closed loop system for plastic materials to help create a cleaner and healthier planet for future generations. Quite a big tagline here or the mission. So in this way, we use the sequential chain where we use the multiple inputs and named outputs were given. It was similar to the simple chain, the simple sequential chain, but just we are not mentioning what was the input and what was the output. We are just combining them here. Yeah. We are not mentioning the inputs and outputs. We are just mentioning the two chains, what they were trying to run. We are just combining them using the simple sequential chain. But in case of sequential chain, we are mentioning the name input and the output. I hope you guys have understood. You guys can practice by giving different prompts and see what would you get an answer. So that is the part. I will move toward the next That is the retrieval QA chain. Okay. Next is retrieval, retrieval QA. Now QA is question answering chain. So QA chain. Now it uses vector search. Okay. I will see what is vector search. This open. Yeah. Now, first of all, this is a simple chatbot. You can imagine using the rack-based architecture. Here, we'll feed the document. We'll create the chunk. We'll embed do embedding vector store. We'll store the vector created or the embeddings created. We'll store it in the vector database like Chroma, and then we'll try to get the question answer. Okay, so retrieval QA chain is basically used to get the question answering. Whenever we have to have the tap like question answering, we will use the retrieval QA chain. Okay. So for that, first of all, we will use now whenever we need a document to load into the format that LLM will understand, that is the document object, which has the metadata as well as page content. For that, we need to get the document loader. So from LangChain dot document loader, we'll import. Suppose now if I'm feeding the LM model text, so I will need text loader. Okay. Then okay, I will use your PDF, Pioneer PDF. Just a second. I will get the document. I will get the. You guys may have heard about the famous research paper that is attention is all you need. So you guys can download that PDF document and we'll work on that. And we'll see how we could feed this PDF to the LLM model and get the question answering done. Okay. Okay. I'm not able to import the PDF document. So we'll go with the simple text loader. So text loader, and after loading the text, we need to create the chunk. So text filter, we'll import the recursive character text filter. Okay, and after creating the chunks, then we need to create the embedding. So from LangChain dot embedding, we'll import the OpenAI embedding. And after creating the embedding, we need to store it in vector store. So LangChain from LangChain dot vector store will import Chroma, and after that we use the from LangChain dot chain import retrieval QA. Okay. Now we need some sample txt file. So we'll save first of all. So for that we'll write some text into the texture or txt file. So we'll name it as raw txt or rack text and dot txt. I'll mention W because you want to write it. So I had tabs and I've got right. Yeah, I'll write from here. So suppose the transformer model uses attention mechanism. Right. It was introduced it was introduced uh in the paper. Uh Attention is all you need. Now I want you guys to create a more txt file by including multiple what we can say sentences here and introduce larger text so that we can do the better thinking. And for now I'm just introducing this. Now we have created the txt file. It will be stored in a directory. Now first of all we need to load the document. So for loader we have text text loader, right? We have text loader. I'll mention the file name. That would be the rag text dot txt. Okay. Then I'll say doc equal to loader dot load. Okay. And I use the filter equal to recursive character text filter. I'll mention the chunk size I'll make it equal 100. Okay. And I'll mention the chunk overlap. overlap equal to suppose 20. Now, whenever you have large text in the whatever documents you are putting, you should increase the chunk size according to it. As my document is too small and is in 100, but if my document is multiple, suppose 200 lines, 300 lines, you can use the chunk size as 1000, chunk overlap as 100, 200. Okay, and if you are using a PDF document to fit, you need to import the primary PDF. Format will be the same. You just need to mention the primary PDF loader. You need to mention the path. You need to copy the path from your directory, mention the path, and the process will be same. I'll mention the chunk size and chunk overlap. Now next would be embedding. Right after creating chunk, I need to create embedding. So for that, embedding equal to OpenAI embedding. OpenAI embedding. Okay. We'll use the default one. Vector store. Vector store would be we have imported a chroma. So chroma from document, and I will mention the okay. I've not created chunk equal to letters dot split document document document, and I will mention the doc, that is this one. And now here I'll mention the chunks and embedding. Okay, embedding. Now I will mention the retriever. Okay, retriever would be vector store. Very good. Okay, vector store as retriever retriever. Okay, I'll not mention the similarity. We'll use the default one. Now I'll build the QA chain. Okay, QA chain equal to retrieval retrieval QA from chain type, and here I will mention the LLM. I'll mention the retriever equal to retriever. Okay, and then I'll get the response equal to QA chain dot run. And last question: who introduced the transformer model? Okay, so that is the question, and I will print retrieval query response. I'll make it with okay. So we got the response. The transfer model was introduced by the authors of the paper. Attention is only needed. In this way, we can build the retrieval QA. It is the question answering also chain, and it uses the vector search opening. Now we'll see the next one. That is the conversational retrieval chain. It is basically the cat file member. So next is conversational retrieval chain, which is the cat file member. Basically, if you want to store the conversation, direct conversation with the model, at that point of time you use this one. Okay. Now for that we'll need to import from LangChain dot chain import conversational retrieval chain. Okay. I'll mention that it is a chat chain. Mention the chain. I'll just copy it from it. From LLM. I'll mention the LLM. Yeah. And I'll say retriever equal to we are using retriever, the same one here, the previous equal to retriever. Okay, I'll mention this name that chat history to solve the previous conversation. I'll mention a query, that is the suppose what is the transformer, what is the transformer architecture, and I will get the response, that is the chat chain, right? Chat chain dot run question query and my chat history. Chat history will be the chat history. Right, history. And I'll print with form. The transfer model was. What was the question? What is the transfer model architecture? So the transfer model was introduced by the author. Attention is only. Now when I check chat history, okay, still empty. So I run it again by asking different question. This is empty. It is not working. So here we LangChain basically doesn't assume that it basically assumes that you might manage history yourself. Example by using the cache memory or a database or a conversational buffer memory. So we have not used that here. We need to do it manually. That is after that we need to see chat history. Chat history dot append and here we need to mention the query and response. Likewise. But in real world cases or use cases, you should go with the conversational buffer memory or using session memory or database. Okay. Now we'll see the types we have learned now. So first of all, we went with the simple chain, that is the LLM chain. Then we went with the simple sequential chain, then sequential chain, then retrieval QA chain, and then conversational retrieval chain. So we'll summarize it one by one. So first one is the LLM chain, which is the basic prompt to LLM. Basic prompt to LLM. Then we have the sequential, simple sequential chain, which is one input and multiple steps. Next was sequential chain, right? Next one was sequential chain, which was multiple input or output. So multiple input and well as output. Then we saw the retrieval QA, right? Retrieval QA, which is first plus after. First plus after. Then we have the conversational retrieval, right? What it was doing, we had chat plus memory plus retrieval. So these are the most main important things which are used in LangChain. And I want you guys to practice more on your own Google Colab or VS Code and see by using different examples. Now here I have only included limited text. You can increase the text to a larger amount or you can use the PDF to work on the whatever the rack-based architecture we are seeing here. So look into more about this topic and I'll see you in the next topic. I'll see you in the next section with the new topic. Till then, bye.